Hello, welcome to today's physics class. In this class, we shall be studying light waves and, in particular, the reflection of light waves. Now, this class is brought to you courtesy O3 Schools JAMB app, available for your PC and your Android devices. You can download the link in the description below the video. And upon downloading your app, you will have to activate it. Now, there's no reason to be afraid of your activation, like they will take your money and you not get your activation. It is guaranteed to work. I have mine, you can have yours, and that will help you follow in this class. And they will try and make your reading a lot easier, as you can actually go there and you can search for questions by topics or by the year they came out in JAMB. It's all your choice. And with that, let's move on. We are looking at light waves. Now, what is light? Light, as you know, is what you're required to see, and it's actually generated by the release of photons. Now, the path followed by a particular photon in space is referred to as a ray, while a group of rays together is then referred to as a beam. So, in practical cases, you will actually never see a ray, but you can see beams. And beams are of several types. Beams can be convergent, they can also be divergent, and they can be parallel. Convergent beams, as the name implies, says that they actually converge to a point. They gather to a fixed point in space. A good place where you can see that is in your searchlight, which is used by rescue personnel to find missing people lost at sea or cruise. Your divergent beam spreads out. It scatters from a point and spreads out, while parallel beams move straight. Your divergent beams can be seen quite easily with the bulb we all have at home. On switching on your bulb, the light spreads out along your entire house. Parallel beams, however, can be gotten with some of our torchlights. And those are the types of beams. Now we move on. From knowing this, the most important thing we must know about light is that light always travels in a straight line. Light does not curve around objects except slightly in diffraction, which we have looked at in the previous topic. So, like I was saying, light travels in a straight line, and this phenomenon is referred to as the rectilinear propagation of light. Rectilinear propagation of light. The name might sound big, but all it says, quite simply, is that light will always move in a straight line. Now, there are several effects of this movement in a straight line, and the most obvious one is the shadow. We've all seen our shadow at different times. At times, the shadow appears long, at times, it appears short. What creates the shadow? The shadow is created because the human or the object within the shadow is opaque. It prevents light from actually passing through him and reaching the space behind. And for that reason, you have a dark space in the shape of the outside of the person. And that's what we call a shadow. Now, we also have eclipses. Eclipses are like shadows, but eclipses are shadows caused by celestial objects. There are two eclipses we can experience here on Earth: the lunar eclipse and the solar eclipse. The lunar eclipse is the eclipse of the moon, and that occurs when the Earth gets between the sun and the moon. And solar eclipse or eclipse of the sun occurs when the moon gets between the Earth and the sun. In that case, you may experience a few minutes of darkness during the day. This is the moon, this is the sun, and this is the Earth. Now, as you are aware, the moon is a non-luminous body. The moon doesn't give off any light. And for that reason, if it is to step between the sun and the Earth, light is unable to reach certain parts of the Earth. And those places experience darkness. And that tells us that we have two types of bodies existing naturally. There are luminous bodies and non-luminous. Luminous bodies are those that can produce light on their own, e.g. the sun, while non-luminous bodies do not produce light, e.g. the moon. Okay, and from this point, we can actually take a question from the app. Now, the question is quite simple. On searching your app, you can find this question in the year 2006, question 37. Question says non-luminous objects can be seen because they A are polished, B are near, C reflect light, and D emit light. Non-luminous bodies. Like previously stated already, non-luminous bodies do not produce light, but they can reflect light. A good example of that one more time is the moon. For that reason, you can try to see these bodies because they reflect light which has already been produced and it bounces back to the eye of the observer. And for that reason, you can see them. Which means in this case, our answer is C. You can see that in your app. Okay, that's good. And from this point, we shall move on to something of immense consequence to all of us, especially the girls, which is the mirror. Well, we use mirrors in our daily lives. What is a mirror in essence? A mirror is simply a piece of glass which has been coated on one side, and as a result of that, it's able to bounce light back. Because as you know, in life, there are three types of objects. We have the transparent, the translucent, and the opaque. Transparent objects, they simply allow light to pass through easily. So you can see through a transparent object. A translucent object, on the other hand, allows light to pass through partially. So you can kind of see through them. Like trying to look through some sort of things. You may be able to see what is in front of you, but not really clear. While opaque objects no let light pass through at all. Your wall is a good example. You can't see through a wall. Now, as you are aware, your glass is usually translucent, but on coating one of the surface of the glass, usually with a silver gray material, your glass becomes reflective. So any light that goes into it bounces back. And once we do this, we've produced a mirror. Okay, our mirrors are of two types generally. We have plane mirrors and we have curved mirrors. Your curved mirrors also have a further breakdown into convergent and divergent. But for now, we shall be starting our focus on plane mirrors. Now, how do we produce plane mirrors? Plane mirrors are gotten from straight pieces of glass. Unlike your curved mirrors, you are gotten from curved pieces of glass. Your plane mirrors are perfectly straight. And as a result, the images they produce have some special properties. Number one, the images produced by a plane mirror are always the same size as the object. Same size. The image produced in a plane mirror will always be the same size as the object. Never bigger, never smaller. Also, the image they produce is at the same distance in the mirror as the object is in front of the mirror. What that simply means is that if I was to have a man, let's take this as a man, standing 5 centimeters in front of the mirror, his image on the other side of the mirror shall also be at a distance of 5 centimeters. If he moves back a further 2 centimeters, the image will move inwards a further 2 centimeters. So they shall still both be at 7, 7. So that really tells us that the image, while the same size, will also be at the same distance. Now, thirdly, this image is virtual. Now, what does a virtual image mean? We have two types of images. Images can either be real or virtual. A real image is an image that can be captured on a screen. What that simply means is if you were to reflect this image onto a photographic plate, you should actually take a picture that you can share. But with a virtual image, you can actually take it. If you put it on a photographic film, all you will get is nothing. You cannot actually see it. That's the basic difference between real and virtual images. So the one you get from a plane mirror is virtual. And fourthly, this image is going to be upright. If you are standing still, the image you see of yourself in your mirror will also be standing. Your image will not be upside down. It will definitely be right side up, just as you are. But the fifth one is a little bit tricky. This one says that the image will be laterally inverted. Lateral inversion. What this means is that the image is spun around its axis of symmetry, implying that if you were to try looking at writing in a plane mirror, there shall be a bit of confusion. You can try this at your house. Take a book, stand in front of a mirror, and try reading it. Your image, while also the book, would not really make much sense. If you also stand in front of the mirror and raise up your right hand, the image you shall see in the mirror will be raising up its left hand, not its right hand. So you notice left and right are kind of switched. That means if I was to take this map to a mirror, what I will see in this mirror will no longer quite be mapped. Instead, everything gets spun left to right. So my P will come first, but instead of appearing as P, this curve on your P will go the other way instead, making it look more like 9. But on the other hand, A, if you look at A, no matter how I switch A remains A because its line of symmetry is parallel to the mirror. So every image whose symmetry is parallel to the mirror remains the same. But if it is not, it gets distorted. So A is A, M would also be M because the line of symmetry is also parallel to the mirror. It is that simple. So every image gets spun around. Those whose line of symmetry is not parallel to the mirror get distorted, but those whose line of symmetry is parallel to the mirror remains the same. This is one example. We could try a different word. Let's say David as a name. If you look at David, this D doesn't have the line of symmetry parallel to the mirror. Therefore, D sort of curves around and looks different. But letter I is parallel. So I remains I. Letter V is parallel, remains the same. A is parallel, remains the same. But our D will also spin. So if you were to take this, if you were to write this in your notes, a good way to know when you are correct, take this you're writing and look at it in a mirror. When the mirror switches it back for you, you shall realize that you now have something perfectly normal. But if you take the normal one to the mirror makes it distorted. And that's what we refer to as lateral inversion. Okay, and that is the property of your plane mirror. And all right, so that's that for our plane mirrors and the property of the image. Now, however, those plane mirrors can also do some other things. If you've ever stood at some mirrors that are curved, and when I say curved, now I don't mean curved in the typical sense. I simply mean two plane mirrors joined together at an angle, something like this. So you now have you standing right here in the center and looking this way. If you ever observe that, you realize that you can see more than one image at times. And that is a property we get based on the angle between the mirrors. So if you have any two mirrors joined together, the number of images you see depends on the angle between the two mirrors. And to get that, it has a general formula, which is that number of images equals to 360 over the angle between the mirrors minus 1. That's the formula. Number of images equals 360 divided by the angle between the mirrors minus 1. That means that if, for example, we were having the angle between the mirrors being 90 degrees, as is common, our number of images becomes 360 over 90 minus 1. 360 over 90 is 4. 4 minus 1 is 3. That means if you're to stand between two mirrors inclined at 90 degrees to each other, you shall be able to observe 3 different images. And with that, we head over to our app to answer a question under this subtopic. Now, this question is quite simple. This question states in 2003, question 21, If an object is placed between two parallel plane mirrors with the reflecting surfaces facing each other, how many images of the objects will be formed? Now, in this case, it's more like this, that we have a mirror here and another mirror here, and the person is standing right here. Now, with this, if you look at this, what is the angle between these two mirrors? That's the first trick of the question. If you have to look at this, they have not turned at all, which means that my angle must be 0 degrees. So if my angle between the mirrors is 0, applying my formula one more time, n equals to 360 over theta minus 1, that would be 360 over 0 minus 1. And as you are aware, anything divided by 0 is what? Infinite. So infinite minus 1 remains infinite. And therefore our answer is A, infinite. It's that simple. So for these questions, the first thing you must identify is the angle between the mirrors. Once you know that, to get your number of images, simply apply your formula. And that is how we deal with angle between mirrors. Now, we shall be looking towards something else. Still on that plane mirrors, we shall be wondering what happens if I rotate my mirror. Here's the thing. On the plane mirrors, there are two laws that govern how the image gets reflected. The laws of reflection. Now, the first law of reflection simply states that the incident angle, the reflected angle, and the normal all lie on the same plane. That means if this was my mirror and I have light incident upon this mirror, the light is going to obviously get reflected. This is incident ray, reflected ray. And then a line drawn from your mirror at 90 degrees is referred to as the normal. What this law tells us is that this incident angle or distant ray, the reflected ray, and this normal all exist on the same plane. While the second law tells us that the angle of incidence is always equal to the angle of reflection. Now please note, your angle of incidence is always measured from your incident ray to the normal, not your incident ray to the mirror. Always from the ray to the normal, while your reflected angle is also measured from the ray to the normal. So in this topic, we do not measure or use the angles we get from the ray to the mirror. Instead, we always use the angle from the ray to the normal. And with that, let's take our first question under this part. Now this question says, a ray of light makes an angle of 35 degrees with the plane mirror. Which means, if I also use the same diagram to analyze, we are being told that it makes an angle of 35 degrees with a plane mirror, which means here is 35 degrees. That's our 35. Or we are being told to find the angle of reflection, which is this angle. Now, as you are aware, before I can go for my angle of reflection, I must first of all find my angle of incidence. And my angle of incidence is the angle from the ray to the normal. And if you look at this, from my normal to my mirror forms 90 degrees. Therefore, I can tell that 35 degrees plus I equals to 90 degrees. Collect like terms, that will be 90 minus 35, and that gives us 55 degrees. And as we told in the second law, the incident angle is equal to the reflected angle. So if my incident angle is 55, then my reflected angle must also be 55 degrees. And that is option A. It is that simple. So for any object being reflected, this is what happens. Now the next thing we shall study is what happens if during this reflection I decide to turn my mirror. And by turn I mean I decide to rotate my mirror about a certain angle. What happens to the ray? It gets deviated. Instead of passing through this expected path, its angle gets shifted. It no longer moves through that. And if you're getting deviated, we now have something called the angle of deviation. And to get this angle of deviation, there's a simple formula, which is that deviation equals to 180 minus 2i. 180 minus 2i. And since you know I equals r, then it shall also be 180 minus 2r. And that gives you the angle of deviation of the ray when the light or when the mirror has been turned. And with that, we can apply a question also from this app. And you can see as we're doing this, we're realizing the usefulness of the app. As you read, as you learn any topic, you can always come back to this app and search questions that have to do with that topic you have learned and ensure that your base is totally covered. And now we'll move on. The question says, a ray of light strikes a plane mirror at an angle of 35 degrees. Angle of incidence of 35. If the mirror is rotated through 10 degrees, what angle is the reflected ray rotated? That speed tells us that the mirror increases its angle by 10 degrees. So our answer will simply be 35 plus 10 equals to what? 45 degrees. And that's all. And if you look at this, notice we're not applying this formula because we're not told to find the deviation. If finding the deviation was what we're after, then we would have applied this formula. Like you can try it right now. If you have to find deviation here, the deviation will be 180 minus 2 times 35, which becomes 180 minus 70, which is 110 degrees. Is that okay? All right. So with this, we've come to an end of our analysis of plane mirrors. Now, how about we take one more question just to make sure this is really grounded in. Our question now is from 2000, question number 14. This question is, an engineer intends to deviate a light ray from its path at 120 degrees. Calculate the angle of incidence. In this case, we are being told that we intend to create a deviation of 120, and we want to find the incident ray or the incident angle that will be necessary for this deviation. Deviation is 120. We want to find incident angle. And to solve that, come and look at this formula for angle of deviation. Deviation equals 180 minus 2i. So if my deviation is 120, that'll be 180 minus 2i, which I do not know. Correct like terms. 120 minus 180 equals minus 2i. 120 minus 180 is minus 60, equals to minus 2i over minus 2 over minus 2. So our angle of incidence is going to have to be 30 degrees. And that is answer or option B. And that's what tells you that if the engineer intends to get 120 degrees deviation of this light, he must start with an angle of 30 as the incident angle. And now let's call it a day on plane mirrors.